Have you ever stopped to wonder, where did the Earth come from? It's a question that has intrigued humanity for centuries, leading to countless theories and debates. Was it a cosmic accident, a product of chance, or perhaps a divine plan? The origins of our home planet are shrouded in mystery, cloaked in the unknown. But science, with its unending quest for answers, has pieced together a narrative that brings us closer to the truth. Join me on this fascinating journey back in time, to the very birth of our planet. The story begins around 4.6 billion years ago, in a cloud of gas and dust. This was no ordinary cloud, but a cosmic nebula, vast and teeming with the raw materials of the universe. In the heart of this nebula, the initial conditions were just right for a spectacular event. The nebula was dense with hydrogen and helium, the building blocks of stars and eventually, of everything else. Gravity, the great sculptor of the cosmos, began to pull these particles together. As they clustered, their collective gravity grew stronger, drawing in more and more particles. This process, known as gravitational collapse, led to the formation of a rotating disk of gas and dust, the solar nebula. It's a process that's as natural and as inevitable as a river flowing to the sea. The center of this disk, under the relentless pull of gravity, became so dense and hot that it ignited, giving birth to our sun. But the story doesn't end here. Around this newborn sun, the remaining material of the solar nebula continued to swirl. Tiny particles began to stick together, forming larger and larger clumps. This process, known as accretion, is how planets are born. Over millions of years, these clumps grew into planetesimals, the seeds of planets. In our own corner of the nebula, one such planetesimal was taking shape. It was a turbulent time, full of violent collisions and incredible heat. But through this chaos, our Earth began to form. It was a raw, inhospitable place, far from the lush and life-filled planet we know today. But it was a start. From this cosmic nursery, the stage was set for the birth of our planet. This is the tale of our Earth's cosmic beginnings, a tale of gas and dust, of gravity and heat, of chaos and order. It's a tale that's still being written, as we continue to explore and understand our place in the universe. In this swirling mass of material, the Earth began to take shape. This was not a swift process, mind you, but rather a gradual, painstaking procedure that took millions of years. A concept that you've probably heard of, but may not fully grasp, is accretion. This is the very process by which our Earth was formed. Picture this, a vast, chaotic cloud of dust and gas swirling around in the vacuum of space. Now imagine these tiny particles of dust and gas starting to come together, to clump and cling to one another. This is the beginning of everything. This is accretion. The forces at play here are nothing short of extraordinary. Gravity, that ever-present cosmic glue, begins to draw these particles closer together. The more mass these clumps accumulate, the stronger their gravitational pull becomes. This causes them to attract even more particles, growing larger and larger. These clumps of matter, now known as planetesimals, continue to collide and combine, forming larger bodies known as protoplanets. Over time, these protoplanets undergo a process called differentiation. The heavier elements, like iron and nickel, sink to the center, forming the core. Lighter elements such as silicon, oxygen, and aluminium rise to the surface, creating the crust. This is how the Earth's layered structure was formed. But the Earth was not the only body forming in this cosmic nursery. Other protoplanets, asteroids, and comets were also taking shape, often colliding with one another in violent, fiery impacts. The Earth was not spared from these cosmic collisions. In fact, one such collision is believed to have played a critical role in the formation of our moon. But that's a story for another time. With this process, the foundations of our home were laid, but it was far from the planet we know today. This was a world of molten rock and metal, a world in the throes of creation. The Earth we know, teeming with life and bathed in blue and green, was yet to be born. But the stage was set, the actors in place, and the grand drama of Earth's evolution was about to begin. Welcome to the Hadean Eon, the earliest chapter in Earth's history. Imagine a world so hot that its entire surface was molten, a seething ocean of lava, bubbling and churning under the harsh light of a young sun. This was Earth during the Hadean Eon, a time when our planet was an unimaginable inferno. an alien landscape far removed from the blue and green globe we know today. But even in such extreme conditions, the first building blocks of our planet were taking shape. The molten surface of the Earth was not static. It was in a constant state of flux, with molten rocks flowing and shifting, solidifying and melting again. This was not a gentle process. The Earth was bombarded relentlessly by meteorites, each impact sending a shower of molten rock into the air, only to fall back and rejoin the restless sea of lava. And yet, amidst this chaos, something remarkable was happening. The Earth was beginning to form a crust. The relentless heat from the planet's interior was slowly pushing molten rock to the surface, where it cooled and solidified. This was the primitive crust of the Earth, the first solid ground on a planet that had been, until then, a world of fire and molten rock. But this crust was not stable. It was constantly being broken up by the impacts of meteorites and the movement of molten rock beneath it. Each time the crust broke, molten rock would surge up to fill the gap, cooling and solidifying to form a new piece of the crust. This was a world in the making, a planet being born from fire and chaos. And so, the Hadean Eon was a time of creation, a time when the Earth was being shaped and formed. It was a time of incredible violence and upheaval, but also a time of beginnings. The molten world of the Hadean Eon was the crucible in which our planet was forged, the fiery birthplace of the Earth we know today. This was a time of chaos and creation, where the Earth was being shaped by powerful forces. One of the most significant events in Earth's early history was the formation of the Moon. This celestial object, which we've come to know as our Moon, wasn't always there. In fact, its birth was a cataclysmic event that forever altered the course of our planet's history. This event is best explained by the giant impact hypothesis. Picture this: around 4.5 billion years ago, while the Earth was still young and molten, a rogue celestial body about the size of Mars, known as Theia, was on a collision course with our planet. Theia, named after the Greek Titan who was mother to the moon goddess Selene, was on a path that would dramatically reshape the Earth's destiny. This wasn't a glancing blow, but a head-on collision. The impact was so immense that it vaporized Theia and a significant chunk of Earth, throwing enormous amounts of debris into orbit. This debris, a mixture of material from both the Earth and Theia, gradually began to coalesce, forming a ring around our planet. Over time, this ring of molten rock and dust began to cool down and solidify. This process, driven by gravity, eventually led to the formation of a single large spherical body, our Moon. It's fascinating to imagine that this catastrophic event led to such a serene outcome, the creation of the Moon that lights up our night sky. The Moon's formation had profound effects on Earth. It stabilized our planet's tilt, leading to a more stable climate and the establishment of seasons. It also influenced the rise of tides, which played a key role in the evolution of life. The birth of the Moon was a violent event, but it played a crucial role in shaping the Earth we know today. So the next time you gaze up at the Moon, remember the tumultuous events that led to its creation and how crucial it has been in shaping the world as we know it. After the tumultuous events of its early history, the Earth began to cool and solidify. During this phase, the Earth went through a major transformation. The molten surface, once a flaming sea of liquid rock, started to cool down. As it cooled, it began to harden, forming a thin, brittle layer, the Earth's crust. This process didn't happen overnight, it took millions of years. As the Earth spun on its axis, the outermost layer cooled faster than the inner layers. This temperature difference led to the formation of the Earth's crust, the thin, solid outermost layer of our planet. It was a slow process, but a crucial one, because without this crust, life as we know it would not exist. The Earth's crust is not a single solid piece. It's broken into large pieces called tectonic plates. These plates float on the semi-fluid layer beneath, called the asthenosphere. This is where the concept of plate tectonics comes into play. Plate tectonics is the theory that explains how the Earth's crust is divided into large slabs that move over time. These movements can cause earthquakes, volcanic eruptions, and even form mountains. It's a dynamic process that shapes our world even today, The formation of the Earth's crust and the initiation of plate tectonics marked a significant milestone in the Earth's history. It was a turning point that took the Earth from a molten ball of rock to a planet with a solid surface. This solid surface was the foundation for the continents, the oceans, and ultimately, life. The cooling of the Earth was not just about temperature, it was a phase of transformation, a phase of settling down. It was the time when the Earth started to become the planet we recognize today. With a stable crust in place, the stage was set for the next chapter in Earth's history. So, as we delve deeper into the Earth's past, remember that every stage, every transformation has shaped the world we live in today. Every change, no matter how small, has played a part in creating the Earth we call home. Water is vital for life as we know it, but where did Earth's water come from? This question has puzzled scientists for decades, and today we'll explore some of the leading theories about the origin of Earth's water. Let's start with the cosmic voyages of the solar system, comets. For a long time, comets were considered the prime suspects. These icy travelers from the outer reaches of our solar system could have bombarded the early Earth, depositing water on our planet. Yet, recent studies of water from comets have shown that the chemical signature of their water is different from ours, leading some researchers to reconsider this theory. Next up are asteroids, the rocky remnants from the formation of the solar system. Although smaller and less icy than comets, asteroids could have delivered a significant amount of water to Earth. In fact, recent evidence suggests that the water in our oceans matches the chemical signature of water found in some asteroids, making this theory increasingly compelling. Last but not least, we have the idea of outgassing from the Earth's interior. According to this theory, our planet's water could have originated from within. As the Earth cooled, volatile gases trapped in the planet's interior could have been released, including water vapor. Over time, this water vapor would have condensed to form oceans. Each of these theories has its strengths and weaknesses, and the truth may lie in a combination of all three. It's also possible that future research will uncover new possibilities that we haven't even considered yet. The arrival of water transformed the Earth, creating the oceans and setting the stage for the emergence of life. Indeed, the story of water is not just about its origin, but also about its profound impact on our planet. From shaping our geography to enabling life, water is truly the lifeblood of Earth. From a cloud of dust and gas to a blue planet teeming with life, the birth of the Earth is a tale of cosmic proportions. It's a story that spans billions of years, filled with astronomical events of epic scale and incredible transformations. We began our journey at the very start, pondering the origins of our home planet. We delved into the cosmic beginnings, a time when the universe was a swirling mass of dust and gas, and out of this chaos, the sun and the planets, including Earth, were born. From there, we explored the birth of a planet, the moment when Earth began to take shape. We learned about the Hadean Eon, a period of intense heat and constant bombardment by asteroids, which helped shape the Earth's surface and create the conditions necessary for life to eventually flourish. We then turned our attention to the formation of the Moon, a significant event that not only gave us our beautiful lunar companion, but also played a crucial role in stabilizing Earth's tilt, contributing to the development of seasons and a more hospitable environment for life. Next, we delved into the cooling of the Earth, a critical stage in our planet's formation. As the Earth cooled, the outer layer solidified to form a thin crust, setting the stage for the next significant event in Earth's history, the arrival of water. The arrival of water on Earth is a topic of fervent debate among scientists. We explored various theories, including the possibility that water arrived via comets or was released from the Earth's interior during volcanic eruptions. Regardless of its source, the arrival of water was a turning point, paving the way for the development of life as we know it today. In essence, our incredible journey from a cloud of cosmic dust to a thriving blue planet is a testament to the power of nature and the laws of physics. It's a story of transformation, resilience, and evolution, played out over billions of years in the vast theater of the cosmos. Next time you look at the world around you, remember the incredible journey that our planet has been on. It's a journey that continues to this day as Earth evolves and changes with each passing second. Thank you for joining me on this fascinating exploration of Earth's origins. Let's continue to marvel at the wonders of our universe, for it holds the story of where we came from and perhaps where we might be heading.